So in this video, I'm going to break down how to graph rational functions. And I assume that you know how to find asymptotes if you're watching this video. If you don't, no worries, I have a whole video. It just takes a little bit of work to talk about how to do that. So I'd recommend checking out my video on how to find asymptotes. So I think it's best if we just jump right into some examples with this. So the first thing that you want to do when you're graphing a rational function is to first find all the asymptotes. So to find the vertical asymptotes, so we just set the denominator equal to 0. And then we just figure out how to solve this. So in this case, I can solve by factoring. So this factors is x plus 2, x plus 5. So my asymptotes are x equals -2 and x equals -5. Then for the horizontal asymptote, so the quick method for this would be to just look at the expression. This is a degree 0 polynomial. This is a degree 1 polynomial. This is a degree 2 polynomial. So whenever the degree on the bottom is larger than on the top, you just automatically get the horizontal asymptote y equals 0. Step 2 is to find any x or y-intercepts. Sorry, this word got cut off, but y-intercepts. Okay, so to do that, well, all right. The y-intercept is probably a little more straightforward. I don't think either of these are too bad, actually, but all you have to do to find the y-intercept is plug 0 into the function. So if I plug 0 into the function, so I get 3 over 10, right? So this becomes 0 plus 3, 0 plus 0 plus 10, so 3 over 10. So I have a y-intercept at 3/10. And then for the x-intercepts, so to find an x-intercept, what you're going to want to do is you're going to want to set the numerator equal to 0 and solve. Because when the top equals 0, then the whole thing equals 0. So you just need to know where the top equals 0. So in this case, this is nice and straightforward. If I set x plus 3 equal to 0, that means that x equals -3 is my y-intercept. So I think it's good to actually note the 2 points. The first point was 0, 3 over 10. So I plug 0 in. I got 3 out of 10 out. And then remember, for this second one, so I set the equation equal to 0. So that means that I set the y coordinate equal to 0, and then I solved. So here are my 2 points, 0, 3/10 and -3, 0. Okay, let's keep going. On to the third step. We want to determine if our graph will cross its non-vertical asymptote. So if you remember back from step 1, we found the vertical asymptote and the horizontal asymptote. So the non-vertical asymptote in this case would be this one. Okay, so to figure this out, you do have to go back and reference your whatever your non-vertical asymptote is, and you set the equation equal to that. So in this case, I'm going to set x plus 3 over x squared plus 7x plus 10. And then just to reiterate this, so remember, my horizontal asymptote in this case was y equals 0. So this is what I want to set this equation to, set this whole equation equal to 0. So is there a value of this equation that would equal 0? Well, yes, there is actually. We already found this value. So remember, this is like something that I think a lot of people don't totally connect with rational functions, where the top equals 0 means the whole thing equals 0. So this is a special thing with 0. If this were any other number, then we'd have a different process. But if we're just talking about 0, all you have to worry about is where the top equals 0. And we already found that point. So this occurs. So the solution to this would be x equals -3. So yes, it crosses at -3, 0. So we'll just remember that for now, and we will interpret that on a graph in a second. Okay, so now we have all the information that we need, so we can move on to step 4. Okay, so now what we want to do is we want to plot all the information that we found, and then we want to find at least one more point in each interval. So this will make sense once we start to sketch the graph. So let me make some space and we will start sketching the graph. Okay, so I went ahead and I set up a little graphing space and I just summarized all the relevant information that we found earlier. So first, let's just go ahead and let's mark where the asymptotes are. So I have one asymptote here at x equals -2. I like to make it a dotted line just so that I kind of visually remember it's not something you actually see. It's like technically an invisible line. The other one is at -5. Okay, and then I also want to plot my points. So let's see, I'll do that in green. So I have 0, 3/10. So I just have to really approximate that. 3/10, sure. And then I had this other point, which is also where my, oops, and I forgot my horizontal asymptote. My horizontal asymptote is y equals 0. I'm just going to go ahead and draw a solid line here just so I don't forget. So I'll just kind of mark that. If it's hard for me to see, sometimes I like to make it solid. Okay, so now I just remember that I've got the horizontal asymptote there. Okay, so now I've got 0, 3/10. And then this other point, -3, 0, this is both an x-intercept, but it's also where my graph will cross the non-vertical asymptote. So -3, 0 is right here. So you just see where it's crossing. Okay, so from here, now we need to find a few more points. And so once you have your graph kind of divided into pieces, so I think of dividing up the pieces by the vertical asymptotes. This is a section, I cross the vertical asymptote, this is a section, and then I cross the vertical asymptote, this is a section. So I just kind of want a few more points because I only really have 2 here, and this is really not enough for me to determine much of anything. So you can just choose a point that you feel is easy to calculate. So let's choose, I don't know, how about -6? So if I plug in f of -6 into this function, so let's see. So if I plug that in, I get, this will equal -0.75. Okay, so I'm going to go ahead and graph the point then, -6, -0.75. So again, I'm just kind of approximating that somewhere like around there. All right, what about in here? I'd like another one just to kind of get the general idea of what's happening here. So an easy point to get here would be -4. So this is f of -4. So if I just plug that into the function, I get +1/2. So let's see. -4, +1/2. I'll just put that somewhere there. And then finally, so in this quadrant, so I can choose -1. Maybe we'll just do -1. So if I take f of -1, that's going to give me also 0.5. So I can just plot that somewhere up here. Okay, so now I think I actually have enough to kind of determine this graph. Now you might not feel comfortable with this, but you once you start doing enough of these, you kind of get a general sense of how these work. So this point here, what's going to end up happening, this is going to look like a rational function. We know the graph of the basic rational function, so it's going to just travel near the asymptotes. You can just kind of bank on that. So since I know where that's supposed to go, I can just have it go near the asymptotes. Same thing can be said here. So it just stays within the asymptotes. You can bank on that. Now, what's going on here? The graph is still going to travel near the asymptotes, but since it's going to go also through the non-vertical asymptote, now what we want to have is the graph to just go near both of the asymptotes that you see here and through this horizontal asymptote. So what does that look like? It's going to do something like this. And so now we have the graph of the rational function. So things we learned. So once you kind of know a point on each side, you can just tend towards the asymptotes. The asymptotes are a major guideline. And if you cut through the asymptotes like we see here, then again, you're still going to have the graph ultimately tend towards the asymptotes. Okay, so let's do another one here. So I would encourage you in this case to find the asymptotes and the x and y intercepts on your own and then hit play when you think you've found that. That's where I'm going to start. Hit play when you're ready. Okay, so first we're going to find all the asymptotes, which in this case I think is simple. So for the vertical asymptote, so I just set the denominator equal to 0. That's going to give me that x equals 3. So that one's nice and straightforward. And then for the horizontal asymptotes, so the top and the bottom are both degree 1 polynomials. So to find the horizontal asymptote, I just take the leading coefficient of these two terms, which in this case is 1. So my horizontal asymptote is just 1 over 1, or in other words, my horizontal asymptote is just equal to 1. Cool. And then to find the intercepts, okay, so once again, I'm going to plug 0 into the function, and this just becomes 1 over negative 3. So I have 1 intercept is 0, negative 3. And then remember, to find the x-intercept, you can just set the top part equal to 0. So set the top part equal to 0 and solve. So that's going to give me x equals negative 1. So my other intercept is negative 1, comma 0. Okay, so I'll table those 2 points for now. So the next thing that we want to do, so I'll make some space here. Determine if the graph will cross its non-vertical asymptote. Okay, so just to remind you of what this means. So this means my non-vertical asymptote, so going back to what we were just doing, that would be the horizontal asymptote. So I want to set this equal to 1. So let's set this function equal to 1. So this is different from the last example. The last example was maybe easier because it was equal to 0. In the case now that this is equal to 1, we have a little bit more work to do. So to solve this, what we're going to do is first we're going to clear the denominator. So to clear the denominator, I'm going to multiply both sides by x minus 3. So that cancels out the denominator, and I'm just left with, in this case, x plus 1 equals x minus 3. Okay, so now what your goal is you want to see if you can solve this, okay? So to solve this, I want to subtract x from each side. So let's see, I'll subtract an x, I'll subtract an x. So check out what happens. The x's drop out, and I'm left with the statement 1 equals negative 3. 1 equals negative 3. Does that make sense? Does 1 equal negative 3? No, it does not make sense. So when you get a nonsensical solution, as we have here, the interpretation of that is that the graph will not cross. Now, if you got a solution for this, like we did in the last one, then the graph would cross. But when you get something nonsensical, then it does not. Okay, so now that I know that, we can move on to step 4 and we can start finding some points and stuff. So let me clear some space. Okay, so I've got a little graph here. I've got all my information. So let's just go ahead and plot some things. So first I'll just mark my asymptotes, x equals 3 and y equals 1. So here's my x equals 3 asymptote. Here's my y equals 1 asymptote. Okay, so I also need to just mark the points 0, negative 3 right here, negative 1, 0 right here. Okay, so these points here actually give me enough information for, I think, this part of the graph, because I need my graph to go through these points and then just go towards the asymptotes. So I just really need one point in here on this side to figure out what's going on with the graph. So if I just choose one point on this side, so this is some point after the asymptote, how about x equals 4? So if I just evaluate what's going on at f of 4, f of 4 will give me 5 over 1, so that just equals 5. So that gives me the point 4, 5. So if I mark that, 1, 2, 3, 4, 1, 2. Okay, there we go. All right, so let me mark that in green. Okay, so now I feel like I have enough information to do this. So I need my graph to go near the asymptote through the intercept. And You know, I just realized I wrote the wrong intercept. This should have been 0, negative 1/3. That actually makes way more sense. So let me start that over. So here's 0, negative 1/3. Okay, sorry. So now this draws much easier. Goes through here like this. Okay. And then for my other one, so I just need my graph to go in here, just stays within the confines of its intercepts, and so we're good to go with this one. So nice and straightforward. So for my last example, so this is one that uses an oblique asymptote. So what I would encourage you to do is, once again, just find the asymptotes, find the intercepts. I'll go through those with you when you hit play. Okay, so first to find the asymptotes, so for my vertical asymptote, so if I just set the denominator equal to 0, I'm going to get that x equals 3. And then to find my oblique asymptote, so let's see, I will use synthetic division for this. So this will be 1, 0, 1. So I can bring the 1 down. 3 times 1 is 3, 3, 9, 10. So my oblique asymptote is y equals x plus 3. If you're not sure how to do that, I have lots of example videos where I broke all of this down. So I can just tell this is an oblique asymptote because this is 1 degree higher than the denominator. Okay, so now let's find the intercepts. So I'll make some space. All right, so now I can plug 0 in to get my y-intercept. So this will become 0 and negative 1/3 for that point. And then, okay, so to find where the numerator equals 0, can I factor x squared plus 1? I can't. In fact, if you tried to set this up, so let's say that I isolated the x squared and tried to use the square root property. The thing about that is, using the square root property, the square root of negative 1 is I. So we can't graph negative I. So what that means is there is no x-intercept. No problem. It happens. Okay, so next we're going to decide whether or not this graph will cross its non-vertical asymptote. Now I want to encourage you to try this on your own before you watch the solution, just because math is not a spectator sport and this will make more sense to you if you try first. In this case, this is the non-vertical asymptote. So you're going to have to set this function equal to the non-vertical asymptote and try to solve it. So I encourage you to try that out, and then even if you're stuck, the only thing that's going to be sprained is your pride a little bit, but it's really not a big deal, right? So just give it a try, think about it, hit play when you're ready. Okay, so I cleared a little space, and so I'm going to set this equal now to that x plus 3. So that's the oblique asymptote, that's the non-vertical asymptote. So to solve this, first I need to get rid of the fraction. So I need to multiply both sides by x minus 3. So this becomes x squared plus 1 equals x plus 3 times x minus 3. And so where do you go from here? Well, you might as well multiply these together, right? So just multiply and see what you get. So I've got x squared plus 1 equals x squared, x squared minus, not minus 3, minus 9. So plus 3x minus 3x minus 9, so the x's will drop out. Okay, so then I can subtract off the x squareds, and now I've got 1 equals negative 9. This again does not make any sense, so we say this does not cross. And now we're ready to graph. So I will make some space. All right, so now I've set up my graph and I've got all my information summarized. So let's go ahead and just first draw the vertical asymptote at x equals 3. No problem. Now, for the oblique asymptote, this is the equation of a line. So we're literally just going to draw a line. It's a line with y-intercept equal to 3. And then the slope of this, well, there's an invisible 1 in front of the x, so the slope is up 1 over 1. And then you can just draw a line, and this is why it's called an oblique asymptote or a slanted asymptote. It's an oblique line or a slanted line. Okay. So now, let's see, I also need to plot the point 0, negative 1/3. So I'll just go ahead and plot that right there. All right, so now, this type of graph actually works very similarly to what we've seen before. It's just, it looks weird because of the slant. So let's grab a point. So remember, the vertical asymptotes are what divide the graph. So I've actually already got a point on this side. It's the y-intercept. We'll choose one more in here just to try to figure out what the graph is going to look like. So just choosing an easy point that's on this side of this asymptote, let's just plug in 1. So if I evaluate f of 1, so let's see, what's that going to give me? That's going to give me 2 over -2, so that equals -1. So this is the point 1, -1. So I can go ahead and plot that. Now, if you're not feeling comfortable, remember, you can always graph a couple more points if you'd like. I'm going to keep going with this just to kind of show you the general shape, but when in doubt, just grab a few more points. It's not a problem. And then a point that's on this side of the graph would be, let's see, 1, 2, 3, 4. I'll just plug in 4. So we've got f of 4. So if I plug that in, that's going to give me 17 over 1, so 17. So that's the point 417. So that's going to be like somewhere up here. Okay, so this is really enough then for me to get like the gist of this graph. So the way that this is going to work, it works with the same philosophy of the other rational graphs that we've seen. You want the graph to travel along the asymptotes, go through the points. It's just going to be like a more slanty graph. So I can go like this. And that's a nice approximation. So that's what happens when you have the slant asymptotes. Okay, so I'm going to end the video here. I do have a few more examples if you want to see more. Feel free to check that out. And otherwise, I will catch you guys in another video. Thanks for watching.